Hello. 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 I am audible.
Yes, sir.
Okay. Good morning to all. Today I will take your class. So myself, Dr. Raghunandan Giri, faculty of this department, uh, Department of Applied Mathematics. So I will wait or I will start because there is 48 participants are joined. I will wait 5 minutes or okay. Let's take the when yesterday queries. Then I will start my lectures. So if any queries of yesterday class, then uh, just ask. I will answer later.
So to call a function, please repeat again today class. I am not able to understand from yesterday class.
Okay, a function the definition and call I will take care next a second session.
Okay,
Second
sir.
session I will discuss.
Okay, sir. Thank you, sir.
Any other queries? Okay, I start my lectures. Okay, today first lecture is on the linear algebra. Um, myself, Dr. Raghunandan Giri, Assistant Professor in this department, Department of Applied Mathematics, Vidyasagar University. So, actually, we know the linear algebra basically uh, matrix manipulation, matrix arithmetics, and some linear equations, uh, system of linear equation, and some problems of eigenvalues, singular values, like this. So, in this lecture, I will cover how to create and manipulate the 1D array, basically vectors, and how to create and manipulate 2D arrays, that is a matrix, and different arithmetic operation. It is visible. My screen is visible.
Yes, sir.
Okay, okay, okay.
Yes, sir.
Yes, sir. Visual, sir.
Okay. Different arithmetic operations on vectors and matrix, and system of linear equation solutions, and by different techniques, eigenvalues problem and singular values problems. So already yesterday class, Samal Babu told the 1D, 2D arrays, the creation and manipulation. I just repeat these things. No, I not go details of these things. I just overview of these things. First, how to create 1D array, basically vectors. The vectors basically three way we can create vectors. First, vectors, if the list of numbers is known. Creating vector from known list of number. When list of numbers are known, then how we can create the vectors. The general syntax is variable name equal to within square the square bracket the list of numbers. The list of numbers must separated by comma or space. Already these things already discussed, Samal Babu. Just I repeat. If the list is known, then in this way we can represent the vectors. The vectors are two types: the row vectors and column vectors. If separated numbers are separated by row, comma or space, then this vector is called row vector. If list of number are separated by the semicolon or press enter, then this vector we call the column vectors. Next, when a list of numbers not known, but spacing, constant spacing. That spacing between the elements are known. Spacing are known. That means second element minus first elements, the difference, and third element minus second elements. This spacing is constant. Then we can create vector like this. Variable name equal to within third bracket m colon q colon n. M means starting point, q is step spacing, step length, n is the end point. Or within without square bracket also we can write like this. This vector is called regular vector. Regular vector. If a middle point is q is omitted, then it is default value is q is 1. Just then other way also create the vectors when the spacing is linear. That time we can create vector like this. Vector variable name is equal to lin pace. Lin pace is a function with argument initial point, final point, and number of points. These are the three way we can create a vectors. Okay, this I will these three things I will show you in the MATLAB software. So my software is visible. Software screen is visible.
Yes, sir. Yes,
Yes,
sir.
sir. Visible, sir.
Okay, first method to create the vectors. I say that if the list of numbers is known, suppose there are five numbers, there are five numbers, known numbers. Okay. 7, 3, 4, 2, 1. Or a real number maybe, but others number 4.1, 8.4, 1.0. This is x is a variable name. This is the assignment operator. This list or vector assigned to the variable x. This statement means there is the five elements in the list, all are knowns. So a list of numbers we have written within square bracket separated by space, or we can separated by comma. Anyway, either separated by space or separated by comma. Whatever you like, you can write. My suggestion, you must put the comma, because comma is visible to anyone, space may not visible to anyone. This way we can create a list of knowns number. There is then other way, second way, we can create a vector which the spacing is constant. Means I want to create a vector from 0 to suppose 0 to 10 with spacing 2. Right? You can create y equal to 0:2:10. In this way, this portion you can put in within square bracket or without square bracket. Both are same. So if I write this, you see that this so that y is a vector from 0 to 10 with spacing 2. 0, 2, 4, 6, 8, 10. Other methods, which suppose z is a vector from when the when the list
তুমি কোথায়? এই শোনো, তুমি খাতা দেখেছিলে না? এখানে একটু সুন্দর কথা
please mute your Abdullah. Third method, creating a vector with a linear pacing. With a linear pacing, suppose z equal to in space, there is from 0 initial point, final point 10, number of points are suppose number of points suppose 5.
আর এখানে এই যে 12টা লিখেছো,
It will create a vectors, creates a vector of 10 vector of 5 points, but pacing is equal. The second point minus first point is 2.5, third point minus second point 2.5. Spacing is equal. Second and third method like similar but not same.
Abdullah sir, please mute yourself. Abdullah sir, please mute yourself.
মিনিমাম ওটা আপনি একটা দেখেন সাথে ওই রেটে হিসেবে মিনিমাম একটা আছে একটা হচ্ছে পরেরটাও 100 তুমি কটা 16 তাহলে এখানে 8টা লিখেছো
Next, these three ways we can create the vectors. Then how can create the matrix or two-dimensional array? Basically, Abdullah Ali, please mute your mic. Thank you. We know the matrix is a two-dimensional array. Two-dimensional array is the matrix. When list of numbers we arrange in row and columns, we say this is a matrix. So how we can create the matrix? The similar way, the matrix can create the variable names. Left side variable names equal to within square bracket the first row separate by semicolon, then second row, then third row, that way last row. So the first row means this is a vector, second row this is a vector, but in matrix first row number of elements in first row and second row, third row are same. Number of rows, the number of elements in first row, second row, last row is same in a matrix. So the first row is a list. You can write any one of three methods. So I see that the x equal to x is a matrix where this is the first row, semicolon, then second row, semicolon, third row. This is or anyway this is the when list of numbers is known. Second method, this is the first row, this is second row, this is third row. Anyway, you can create a row any one method which I have discussed earlier. Any one of three methods I have just told you. So, like way we can create matrix. Okay. So, uh, just how can create array matrix? Already yesterday class, Samal already covered. I just I recall you. Uh, because the linear algebra base depend on the matrix and vectors. So how can access the elements of array and matrix? This is the operator colon operator. Using the colon operator, we can access any individual elements, row, columns, or sub-array. This already told the Samal Babu in last
Excuse me,
class.
sir. Can you repeat the line space? How can we create the matrix with line space? Can you repeat that one?
Okay, okay. Line pace. Line pace. This is a built-in function. Line pace. Line pace is a built-in function which has three arguments. First argument is the initial point, then final point, then how many point how you want to divide the interval 0, 10 interval with equal pacing. Suppose 100 you want to divide this 0, 10 interval into 100 points. Then the vectors return by this function. See, this function return a vectors from 0, start with 0, ending with 10. There is 100 points of equal pacing. Are you getting?
Yes, sir. Thank you. Thank you.
Okay. Then now how to indexing any vector or matrix? How to indexing? So suppose A is a array of 5 elements. We can create like this. So if we access the element of the vector A, then you have to put the variable name, then within first bracket the index number. So within first bracket, if you want to access the third elements, you put the third 3. Then you get the third element of the list A, that is 6. If you want if you want list of elements, not individual element, a list of elements. Suppose you want 4, 6, 8. The position of 4, 6, 8 is 1, 3, 5. So just within square bracket put the index 1, 3, 5. Okay. Then it will return the value is 4, 6, 8. 4, 6, 8. So, this way, if you access the elements, regular elements, suppose from this 2 to 4, from 2 to 4. So you can create a list like that 2 to 4 with regular pacing order. Then you return 5, 6, 7. Then you return 5, 6, 7. Then you return 5, 6, 7. Okay. if you put just colon A within the parenthesis colon, that means index start from 1 to end. 1 to end. 1 to end means 4, 5, 6, 7, 8. All these elements. See this? All the 4, 5, 6, 7, 8. So in this way, we can access the elements of a vector. Also, we can access the element of the matrix. Suppose A is a matrix of 1, 4, 7, 7, 2, 5, 8, 3, 6, 9. A is a matrix. So, here is a two-dimensional array. Is a two-dimensional array. So two index is required to access the individual elements. Two index are required. So A indexing within parentheses, we have to write the index number. So two index, first is the number of row. First index is row number, then comma, then second index. This is number of column. So two index are required. First index is row number, second index is column number. So if individual elements you want to access, individual elements means second, third position. Second row, third column. Second row, third column means 8. This return the 8. Individual elements you can access. You can also access the list of row number. So first row, second row. First row, second row, column numbers also. Column হচ্ছে second and third column. Column second row, third. Second, third. So first you see that the comma is separator. First row, then comma, then column. If the row indices are a list, you put within as a vector. Similarly, if the column index is a list, you put it as a vector. So this one return first row, second row, and column third. So 4, 7, 5, 8. This will return. See that 4, 7, 5, 8. Like this way, we can access the element of matrix. Okay. Any question? Hello?
No, sir.
Okay. So, now, in earlier language, C language or C++, it is very difficult to write a vector or matrix like this simply way. Also, in C, we know that this is the array is a static data structure, but in matrix, here is a flexibility. We can access, we can extend and increase the array size or decrease the array size. But means we can extend the vector or matrix or reduce the size of vector or matrix. Okay, all data in the MATLAB are matrix form. All data are stored in MATLAB matrix form. So here array, I will just show you how to extend the array size, how to reduce the array size. Okay. But this operation not perform in C. This is very difficult to extend the array size or delete the elements from any array. Suppose X is a array which has 9 elements. Yeah. So X is a array of 9 elements. Yeah, X 9 elements is there. Suppose X is a array of 9 elements. So, I want to extend this. You see the size of array, size of X. You can check by there is a function between function size. Okay. There is a size 1 row and 9 column. There is a size of X. I want to extend the size of X. So I putting X 10 equal to suppose 100. Then see that there is a X vector. Earlier there is a 9 element. Now it is 10 elements. Suppose size of X is 1 by 10. So in this way we can increase the size of a vector. Also we can reduce the size. We can delete any element, any portion of the this vector. How? See, suppose X in this case I want to remove the second to second, third, fourth, fifth, sixth. Second to sixth element I want to delete. Second position to sixth position. Okay. So how you do? See X within parenthesis the index number second to sixth that will assign just nothing, null. Okay. Then see X already reduced. Okay. From 2 to 6 position, there is these elements are already deleted. Then size is reduced to 10 to 5. In this way, we can extend the array size. You can reduce the array size also by deleting the elements. This is a very tough job in C language. This job is very tough in C, but in MATLAB it is easy. Just you put this statement, it will show the result. You can also is a matrix 1 4 7 8 3 6 9. Okay, say is a matrix. So in matrix you can extend either one row, okay, or one column, but you can delete rows or columns, okay? Not particular elements. You cannot delete a particular elements. You have to delete either rows or columns. All the elements of that particular rows or particular columns. So I want this is the see the size of A. Size of A is a 3 by 3 matrix. Size of A is 3 by 3. 3 by 3. Means three rows and three columns matrix. Now I A equal to, suppose I write it A equal to earlier A means by 3 matrix, comma A column 4 column vector 4 5 8. See this statement carefully. A equal to earlier A means 3 by 3 matrix, then append a last columns, fourth columns. See the matrix. Matrix is a 3 by 4 matrix. Size of A is 3 by 4. 3 rows and 4 columns. Just earlier, there is a 3 rows and 3 columns. I append 1 columns at the end of the earlier A matrix. The new A matrix is the 3 by 4 matrix. See this? Like that way, we can extend the matrix size also. We can reduce the matrix size just putting any rows or columns equal to nothing. See? So I want to remove the first column and second column. First column and second column. So first column and second column. So there is a two columns. So list first and second. The index number first and second. This is the column index. There is row index. Row means all the rows of first and second column. So all the rows, for all the rows there is a colon open. This equal to nothing. And see the A is 3 by 2 matrix. First two column we have deleted. So in this way we can reduce the size of the matrix. Okay, just I will cover the how to create a 1D arrays, 2D array, how to manipulate, means how to access the elements of the vector and matrix, and how extend the vector and matrix size, and how reduce also vector matrix. This I will cover. Next I will go to some Pearson matrix. Okay, some Pearson matrix. These are the function already built-in function already have in MATLAB software. These are frequently used matrix. So for identity matrix, n by n identity matrix, there is a function in. For for ones matrix square matrix ones, 0 for 0 0 magic.
Sir. Hello.
Hello.
Sir, can you show again how to remove the first and second column, because the screen was not visible then?
Okay. But how remove the first and second column of a matrix? A is a 3 by 3 matrix. Now I put A is a 3 by 4 matrix. Then A is now size of A is 3 by 4. Means there is a 3 column, 3 row, 4 columns. So I want to delete any two columns. First, suppose first column and third column. First column and third columns. So first, write the variable names A, the index within first bracket. I want to remove the column numbers. So there is a more than one column. So put it in list first column and third columns. Okay. These are the column numbers. So first columns, all the rows, all the numbers. Say third columns, all the numbers. So row index is the all. For all, we know the column. Column means the first to end. Okay. Otherwise, you can write also like this. 1, 2, 3. But 1, 2, 3 maybe not work. I could not check because it is the software. It not check. All are within list. So for this is also complete list, but software syntax is these are both are same, but colon operator. This is best way to write, and the software easily understand. Put this null, then the first and third column is deleted from A. See the A is the 2 by there is a 3 row and 2 column already deleted. You are
Okay,
getting?
sir. Yes, sir. Thank you.
Okay, just then I some special matrix. There is a name. Just see I is for identity matrix, for one matrix ones, zero matrix zeros, and magic is a one special type of matrix in MATLAB. I discussed rand n, rand n, rand in. Okay, these are the function I made to create use to create the matrix. I will just write. Suppose A equal to I5. I5. This function will return a square matrix, identity matrix, high order identity matrix. See, B equal to magic of 4. This is a magic matrix. See, this matrix created from 1 to 16 element. From 1 to 16, all are distinct elements. 1 to 16. There are specialties is there. All row sums and column sums are equal, and diagonal sum also equal. Okay. So this is a magic matrix. Suppose rand is a function. Rand, suppose 4. This create a square matrix of order 4. All elements are between 0 1 from the uniform distribution, quality distribution. All elements from 0 to 1 distributed from uniform distribution. If it is from random distribution, normal distribution, then rand n function is there. Normal distribution. If the numbers are generated for normal distribution, then rand n function is rand I for integer random numbers. The maximum numbers, suppose 100 of size is generated a matrix square matrix of order 4 whose elements between 1 to 100. See, all the elements of the square matrix are generated within 0 to 100. These are the special matrix already MATLAB have. Okay. These are the frequently used matrix. Okay. Now I will tell you the operations on array. Okay. So first of all, the operations, arithmetic operation for matrix. Okay. The addition for addition, A is a matrix, A is matrix on matrix, and B is on matrix. A and B. If the size of matrix, we know the size of A, B are same, means A is a matrix of order m by n, and B is a matrix of order m by n, then addition and subtraction operator are compatible. So we write A plus B for matrix addition, A minus B for matrix subtraction. If the size of two matrices A, B are not same, then these are not compatible. Means dimension mismatch. For matrix multiplication, you know the multiplication are computable if the column number of A equal to row number of row and B. Suppose A is the order m by p, and B is a matrix of order p by n, then product AB of size m by n. Okay. So if A is a matrix of m by p and B is a matrix p by n, then A star B is defined and give the result. Give the result a matrix of order m by n. The other two operators, there are new operators, the right division and left division. These operators come from the operational system of equation, solution of system of equation. Suppose Ax equal to B is a system. The solution of these systems, we know Ax equal to A inverse B. So in MATLAB, we write this like way: A backslash B backslash A backslash B. So backslash means it's a left division. Backslash is a left division. Okay. Division means A inverse is multiply in the left, so is the backslash is the left division. Another right division. Right division, what we do is for the system. Suppose C x equal to D. This is the system. C x equal to D. The solution. No, sorry. Suppose system is xc equal to D, then x equal to D into C inverse, D equal to D into C inverse, that we write D slash C. The slash means this is the right division. Divided, D is divided, this backslash, the right of the slash is divide. So is the right division. In matrix division, for matrix, we have two the division slash. This is the right division and backslash the left division. The value, you see that value. Suppose 2 divided by 4, we know that this means 0.5. 0.5. 2 backslash 4 means 4 by 2. This is 2. You see that? This is a scalar system. Scalar is a 1 by 1 matrix. Scalar is also 1 by 1 matrix. So here that the right division, the operator is the slash. The right is divided to the left number. Similarly, for backslash, the left number is divided to the right number. So this is the left division. This way the operator names is the right division or left division. So these operation for matrix. For vector, the operation is the basically element-wise operation. Suppose two vectors x one vector or y one vector. Then the addition and subtraction of two vectors are compatible if the size of x and y are same. This is a vector, x is a vector, y is a vector, means size means the length of x equal to length of y, then the addition and subtraction between two vectors is possible. If x is a vector and suppose c is a scalar, then addition subtraction means all the elements of x are added or subtracted by c. Plus the scalar is added to a vector a. The scalar 2 added a vector 6, 3. Then its result would be 6 plus 2 or 3 plus 2. That is 8. Similarly, subtraction also. Then a, b, two vectors. A, b, a, capital A plus capital B. A or B are two vectors. Then the addition is the individual components. 6, first component plus first component, second component plus second component. That is. And subtraction also. All are component-wise operation for vectors. For matrix, that is different. For vectors, all are component-wise. But this multiplication star operator, we already see that star means the matrix multiplication. This is compatible if the first matrix, the number of columns, and second matrix, the number of rows, the same, then the star is compatible. So if you write that for two vector, A is a vector and B is a vector, A star B, this operator is undefined, not compatible. So for vector, we have to write dot star. How this work? This work the component-wise multiplication. See, the 3, 5 dot star 4, 8. 3 into 4, 12. 5 into 8, 40. Similar way, there is a right division dot slash dot backslash all are component wise it is performed. That dot caret for exponential. You see, a dot caret b, maybe a is a vector, b is a vector, or a is a scalar, b is a scalar. Three possibilities there. So when a is a vector, b is a scalar, see there individual element is the exponent. 3 square 5 square. When b is a vector, a is a scalar, 2 dot caret 3 to 3 comma 5. That will be the component 3 cube, 2 to the power cube, or 2 to the power 5. A similar way, when a and b both are vector, then 3 square 5 to the power 4. This is the exponential, element wise exponential. These are the operations for vector and matrix. Some function, common function used for the array. That's the length. Find out the number of elements of a vector. If A is a matrix, then the maximum largest value of the row and column numbers. Size is return the row number and column number. Max is a function that return the maximum of a list. If A is a matrix, then it return the for the maximum value of each columns. Similarly, minimum is the same as max, return only minimum value. Sum is the sum return the sum of the list. If it is a matrix, then the column sums. Sort is a function that is sort a list. If A is a matrix, then it sort the column of ascending order. The norm is a function to compute the distance, geometric length or distance, like this. So, okay. Any question?
No, sir, it's fine. Okay, sir.
Suppose x is a array 2.1, 3.5, 4.0, 5.6. Ax is a array. So the max of x, what it return? It will return the maximum of the list. What is the maximum value?
5.6.
5.6. So it return 5.6. If you take two, you see that if you take a max function also return two values. See, those Q, I will take two output values of the function. Then first is the maximum value, second is the index, position of the max. See, the first p value is the 5.6. This is the position. This is the maximum value. And q is the position of the list. Yeah. Similarly, minimum also minimum of x. Minimum of x means what is the minimum value?
2.1.
2.1. This is the index number one. So a p value is 2.1 and q value is 1. See? Sorry, mean. Mean. M-I-N. Mean. See? If suppose A is a matrix, okay, sum value, sum of x. Sum of x. Sum of x is written the sum of the list. This sum values is 9, 12.1, 15.1, 17. How much sum is the list? Hello? How much sum of the list? List of numbers? This will written
14.1.
2.2.
15.2. This is the sum. For list, also the length of x, it will written the 4 number of elements of the list. 1, 2, 3. Okay. If A is a vector, suppose A is a matrix. Suppose the matrix 1, 4, 7, 2, 5, 8, 3, 6, 9. Nine, 6, 3. See, A is a matrix. A is a matrix of size 3 by 3. So when you perform the max of A, it will return the column maximum. There is first column 1, 2, 9. The maximum value is 9. Second column 4, 5, 6. Maximum value is 6. Second column, the maximum value is 8. So it return 9, 6, 8. 6, 9, 6. Return a row vector. The maximum of the column, each column.
For row maximum, what will do?
For row, just you write that transpose.
Okay.
Maximum of a transpose, but transpose that will return a column, that also return a row vector. Then you have to hold transpose. You have to transpose or hold. Then it will get the correct result. See, the maximum value is 7, 8, 9. 7, 8, 9, 7, 8.
Sir, I have a question.
Okay.
Okay, suppose please go through the command where you have taken p comma q is equal to max x. Suppose there is 2 maximum entry in x, then what will be the value of q?
Both the index that will return.
Okay, both index should be returned.
This is a list of index. List of values and index. See?
List of values.
Okay. See this. Suppose there is a 1, 2, 2.5. 1, 2, 2.5. There is a multiple maximum value. 2 maximum values you get. Suppose P, Q equal to max of x. Max of it. See? Okay, return only first maximum value.
Yes. The first maximum value and its position will be returned.
Position. Okay. Sorry, I not checked earlier. You just
Sir, I have a question.
Okay, thank you, sir.
please.
Sir, I have a question.
Please ask.
Suppose, sir, I have a matrix. Now, if we want to find the maximum of the first row or any particular row, then how we write?
Okay. Suppose A is a matrix. Like this. We want the maximum of the first
Find
row.
suppose first row maximum first row.
Okay. For first row, the for the first row, you know that all the rows element of the first row. So row number is on the columns. Okay. This will return the only the first row. See, this is the first row. Then you want the max. So put max of this. Just indexing. We have told just put this. This will return the maximum of the first row. Simple.
Okay, sir.
You getting? Hello.
Sir, I have another question. Suppose I have a matrix. A. Now, if we only want to display the first column and third and fourth column, then it is possible.
Whatever you want, it is possible. Suppose this is a matrix. This matrix is a 3x3 matrix. So you want the first column and third column. Suppose.
Yes.
First column, third column. Okay, you just put A equal to all the rows of first and third columns. This will return only the first and third column. Okay.
Okay, sir.
Okay. Now I start next linear algebra. Just system of linear equation. I go to the system of linear equation. All you know, I think most of you are from engineering or mathematics background. I think.
Sir, after the class, please share your PPT.
There is a recording. This lecture already record. Coordinator sir will send you the record.
Actually, forget to record, sir. So, if possible, sir, please share
Coordinator
this
sir
PPT.
already record these lectures. You will send.
Okay, sir. Thank you.
Okay, now I start the main portion. The system of linear equation. All you know, system of linear equation. We can matrix form. We can write it Ax equal to B. It is visible. I write that worksheet.
Yes, sir.
Yes, sir, visible.
A is the coefficient matrix. X is a vector, B is a vector. X and B are both are column vectors. Already known. So A is the matrix. If A is a matrix of size n by n, we say that this system of linear equation is a square system of linear equation. If it is not, it is m by n. If n is more, means number of equation more than number of unknowns. M greater than n. This is over-determined system. And if m is less than n, it is underdetermined system. Three type of system. When it is the square system, A may be a matrix, may be singular, means dead. Non-singular is dead value equal to not equal to 0. You know, if it is singular, dead value equal to 0. So there is many possibilities. I go one by one. But this system, the solution of the system is just get by x equal to a backslash b backslash. In MATLAB, it is we get the result x equal to a backslash b. Whatever a may be square matrix, may be rectangular matrix, whatever may be, but we get the result, the solution x equal to a by b. If a is a singular matrix, then it gives a warning. It gives warning. So okay. See, is a square. If the m equal to n, the square system may give the exact solution. A certain condition is there. If m greater than n, the over-determined system, here we on the least square solution. If the number of unknowns less number of equation is lesser than number of unknowns, this is alternate determined system. Find a basic solution. So in generally a system of linear equation, how you get the solution? This is a system of linear equation, ax equal to b. Is the solution? First, the corresponding homogeneous equation ax equal to 0. It's the solving this gives the basic solutions of the system of homogeneous equation. Then a particular solutions of the system of non-homogeneous ax equal to b. Then we add the particular solutions with the linear combination of the basic vectors of the solution set ax equal to 0. This is the general solution. We already know this is in mathematics, but here we find how to find the solutions of the system. If system is a square system, means A is a square matrix. If A is a square matrix, then the square matrix and A is a non-singular. Then the solution x equal to a backslash b. This is the solution. See, suppose a equal to the coefficient of the system a equal to, suppose a equal to 1, 3, 7. First row, second row minus 1, 4, second row, third row, 1, 1. This is the coefficient matrix here. See the determinant value of the A is minus 20, so A is a non-singular matrix. So this system, right hand side of this system, suppose 5, 6, 3. This is a column vector. B is a column vector. The solution of the system x equal to how will you get A backslash B. A backslash B. Okay. This is the solution of the system. Since A is a non-singular matrix, the square system has a unique solution. This is the x equal to x. MATLAB give the backslash operator is executed by the methods of Gauss elimination method, using Gauss elimination method. Also, we know that the solution also we can get. The solution also we can get. Suppose ax equal to b, then x equal to A is a non-singular matrix, then A inverse is exist, A inverse into B, it is also solution. It is also solution. So see A is a non-singular matrix, so inverse also exists. So inverse INV, inverse of A, INV is a function to find out the inverse of A. Inverse star B. This also gives the same result, but this inverse calculation, it is time consuming. This way is not efficient. Inverse A star B, it is not efficient, but A backslash B, it is efficient because it is require lesser time. Okay, now when this is A is a non-singular matrix, then we get the result in this way. Second, if A is a singular, now A is singular, the solution of A x equal to B either does not exist or it is not unique. So backslash A backslash B is give result if A is a singular, but it raises some warning. Some warning is gives. Warning is A is nearly singular, raises an error condition. This warning will show. If A is a singular and Ax equal to B has a solution, then we get the solution by this way: Ax equal to PINVA star B. Okay. This gives the least square solution. If Ax equal to B does not have an exact solution, then P returns a least square solution. Okay. Then how to check the system Ax equal to B has an exact solution or not? You already know the in algebra we have checked a system of homogeneous system of equation has solution, exact solution or not, by putting the in the rank of augmented matrix A, comma B, in the augmented matrix, rank of A equal to rank of this matrix, augmented matrix, and rank of A are both same, then the system has this exact solution. You already know. So I will show you. If A is a singular matrix, I take one matrix. I take a matrix which is the singular. Suppose 1, 3, 7 minus 1, 4, 4, 4, 4, 1, 10, 18. This is a matrix. See, the dead value of this matrix is 0. So A is a singular matrix. Now I take the right hand vectors, column vectors. I take right hand column vectors. Suppose 5 semicolon 2 semicolon 12. Right hand vector 5 to 12. Okay. Then the solution. See the solution P inverse means pseudo inverse PINV of A into B. This is the solution. So this solution, this is the solution of the system which is whose coefficient matrix is singular. But this solution is may be exact solution, may be approximate solution. See, this solution is, if we return back this solution x into the A, we give the right hand side vector, then we say that this is the exact solution. I type A star this A star x. This gives the 5 to 12. 5 to 12 means this is B vector. So this solution is the exact solution. See, I tell you that A is a matrix which is singular. The system has solution by P inverse method. This method will give you a solution. Suppose x star, we get x star by P inverse A into B x star. If A of x star gives the value B, and if this B and this B is same, then the x star is the exact solution. Here we see that for this singular matrix we get the exact solution. Just A into x give the B vector. Are you getting my point? Hello?
Yes, sir.
Next, I will show you that.
Sir, what is the function of the P inverse?
Okay, I will discuss that with P inverse. This is pseudo inverse. Those matrices are singular. You cannot find out the inverse. So there is a function, that's a least square approximation method. Using the least square approximation method, find out the inverse of the matrix. Generalized inverse. This is the P inverse. So A is the matrix like this. A is the matrix, and B is the right hand vector. Not earlier, it defined newly. C semicolon 6 semicolon 0. Okay. 360. Okay. Then the solution, suppose x equal to P inverse of A into B. P inverse A. This give the result. This is x is a least square solution, not exact solution. This is approximate solution. So how we state that A star x is not given the B. It keep -142, but our B is 6360. So it returns, it does not return the original B. So this is the exact, not exact solution. So earlier I told that for some system we get the exact solution. For some system, for particular matrix A and B, we does not get exact solution, that approximation solution. So how to check this? Also there is a process to check this. The if the we know the argo, row reduced form of the augmented matrix, that means a a comma b. See, this is the system is inconsistent. For that B, the system is inconsistent. You see that right hand side there is all zero, but left hand side all are zero, but right hand side there is a value 1. So this system is inconsistent. We know that the inconsistent system there is no solution. But here, here we get the approximate solution.
Excuse me, sir.
Excuse me.
Sir, I have a question that when we are solving the AX is equal to by black right slash
Backslash.
right backslash B. Yes, sir. Then they are using the concept of Gauss elimination method. When we are using the pin V in
P in
behind
pseudo
pin
inverse
V.
P in B.
Yes, sir. What is the concept behind this? Which method it is using now?
There is a system AX equal to B. AX, I suppose there is maybe I written this. Okay. AX equal to, but AX equal AX minus B. There is a norm of this form is minimized using the least square methods. There is a AX minus B is a norm of the this is equilibrium distance. They minimize this. There is a possible value. There is separate possible values of X. Okay. Minimize the possible. There is several possible to find out the minimum of this norm. Okay. So here A is find out in such a way that A matrix is find out in such a way that there is a set of X such that whole is minimum. This procedure is called the pseudo inverse, P inverse, PIN. Basically, P inverse is the generalized method to find out the inverse of a matrix, which is, if the A is non-singular, then P inverse and inverse both are same. If A is singular matrix, then we cannot find out the inverse of the matrix. For that case, the generalized inverse method is used to find out the inverse of singular matrix. This process is called in MATLAB pseudo inverse. We write the function for that PINV. Are you getting?
Okay, sir. Okay, sir. Thank you, sir.
Sir, I have a question. Sir, can I apply P inverse for underdetermined or overdetermined system?
Everywhere you can use.
Okay.
I go through that. I will go, but there is a Now the square system is for square system. It is all right for all. I just told
Yes.
that if A is a non-singular matrix, then it is okay. The solution by backslash method. If A is a singular method, there may be exact solution, may be approximate solution. Exact solution how to get? Both are getting from P inverse star B, but how to check? It is checked by augmented matrix. If augmented matrix there is a on there the augmented matrix, see the rank of the coefficient matrix is 2, but rank of the augmented matrix is 3. So rank both are not same, matrix A and augmented matrix, so it is approximate solution. Okay, any question? Then there is a other system, over determinant system, under determinant system. So I will take a 30-minute break. After that, I will complete this, and then I tell you the plotting, graph plotting also. So if you do not have any question, then I will take a break for half an hour.
Yes, sir. Thank you.
Okay, thank you.
Okay, sir.
Thank you, sir.
Okay, sir.
Okay. Next, I will start it at 2 o'clock.
Okay, sir.
Okay, sir.
एवढी